This is the Conifer chamber with a clip at the front to secure the upper and lower jaw together when the chamber is filled. This ensures a good seal around the conifer needles or branch. The 3 screws are in the same place as with the other chambers to attach to the handle. Push down and begin to tighten the 3 screws by hand. Then using the jaw adjustment tool to tighten each screw just until the plastic of the tool begins to bend. Be careful not to over tighten to avoid damaging the electrics within the handle. Take the spring and the upper jaw, position the spring in the recess, and check which side the metal pin and the hole are on and which side the slot is on. The side with the hole should be slotted in place first by holding the upper jaw securely and levering it down, sliding the metal pin into place on the other side. Check that the 2 jaws are fitted tightly together. Fit the PAR sensor in place and then line up the 2 red dots on the cable connector which attaches the lower jaw to the handle. Use the clip to secure in place neatly along the groove of the handle. Release the clip at the front of the jaws in order to latch the jaws open for storage. If you are using a light unit, the Conifer light unit has a black clip on one side and a cable which attaches here. It is easier to fit the light unit with the chamber closed. Position above the top jaw and find the grooves running along either side of the light unit and the lower jaw. The light unit will click into place on either side. Check it is secure and then connect the cable. Find the Configure menu and we want to change this to Conifer. Find the Conifer option and use the tick to select. You will note that the parameters on the configuration page now change to read Conifer. The leaf area, boundary layer resistance, the log file, flow rate, temperature method. Next, perform a flow check. When entering the flow check menu, an analyzer reference flow check will be completed first, giving you a value. Press OK and it will automatically run the analyzer analysis flow check. Once the reading has stabilized, you can press OK again to save this data with today's date. Next, perform a CO2 zero. Once the reading on screen has stabilized, you'll see that in this case it is too high, the value in red, with a downward arrow denoting that the value needs to be decreased. Use the CO2 calibration tool found in the small toolbox. Make sure that the tool fits securely into the pot adjuster in the lower handle. turn to reduce the value to within an acceptable range and press OK. The last calibration date will show today's date. Use the power button to save this data and to exit the menu. This is the soil chamber. The PAR sensor and a pressure release valve are on the top, and underneath is a fan for mixing the air. The 3 screws align with the handle. This is the lower part of the chamber, the soil collar, and the sealing base if you are using this for a whole plant or for fruit. Also supplied is a soil temperature probe or thermistor. Position the handle on top of the upper soil chamber and securely fit the 3 screws in place. Turn the chamber over and begin to tighten the screws by hand. Next, use the jaw adjustment tool again to tighten each of the 3 screws, just until the tool starts to bend. Now enter the configuration menu again and select soil pot for this type of chamber. It is important to run a flow check, particularly when changing to the soil pot, because the area and the default flow rate are different for this chamber. Save the configuration and then run a flow check as before. Here you can see that the soil chamber is not attached, and so air can flow into the system, bringing an on-screen error that the chamber is not closed. You will see that the parameters on screen have changed. They now read NCER at the top, which stands for net CO2 exchange rate. W flux is the water vapor flux. These are all soil chamber parameters. A CO2 zero calibration is advisable when the soil collar is installed in the ground.